channel Chalk Endo Physics. In today's lesson, we are going to explore the magic and wonders of velocity and acceleration. We'll also consider uniform acceleration and uniform velocity. In a situation of real-life situation, we are going to apply this velocity and acceleration into real-life situation. As you are moving from one point to another, you are accelerating. What is the velocity? As you are driving your car and look at the speedometer and you mark the accelerator brake, what is the acceleration? If you are changing your position with time, for instance, you are moving from one point to another, or you just drive a car and when you get to a traffic and you stopped, what kind of velocity, what kind of quantity is that? That is either the non-acceleration or non-uniform or uniform acceleration or velocity. So we are going to consider the velocity and acceleration in this lesson. So let's explore it. But we are going to use a tree diagram in order to illustrate it very fast to your understanding. So pick up your paper, your pen, and use hands-on engagement so that we further the discussion and the application. Let's start. Physics behind velocity and acceleration.
Again, about again, so the pop up, the penny pop up.
Physics behind velocity and acceleration. We have physics behind velocity and acceleration. Physics behind velocity and acceleration. So we are going to use a tree diagram in order to easily explain velocity and acceleration. Velocity, we will define velocity. We will now have the average velocity, then application of velocity to real life situation. Then in acceleration, we have the acceleration, and we also have uniform and non-uniform acceleration. Then we apply the real life situation into it. As we are considering the both, we are going to explain first the the velocity. We said velocity is the rate of change of displacement with time. You can call rate of change of displacement with time. Rate of change of displacement with time. That is velocity. Velocity is measured in meters per second or meter per second, and also the formula for velocity is is the change in displacement all over time. That is the formula for velocity. For instance, let's apply this velocity in real life situation. For instance, example 1, a car displays from a point A, that is 20 meter, displaced from a point A 20 kilometer in 2 seconds. That is 20 kilometer north, call it north. A car displaced from a point A 20 kilometer due north in 20 seconds. What is the velocity? First and foremost, step 1, you use an acronym called IC. IC is first you identify, acronym called IC means identify the variables, try the variables or the parameters. Then 2 means is what we are going to use this acronym called IC in order to solve this problem. And it said a car displaced from a point A 20 kilometer due north in 2 seconds. What is the velocity? First and foremost, velocity has to do with direction and displacement. So you are going to write here, solve it here, 20 kilometer, this is 20 kilometer, that's illustrations, and also you have in 2 seconds, this is the distance, this is the displacement, this is the north, in 2 seconds, 2 seconds. So what is the velocity? The velocity now we have is, we have been able to identify the variable. Number one, identify the parameters. Step one. Identify the parameter. What are the parameter? Parameter is this and this. So you now say displacement is 220 kilometer and time
Up.
and time which is equals to 2. So in this real explanation, we are going to enter into step 2 because of the space. Going to enter into step 2. Step 2 is you are going to apply the formula displacement all over time. So you now said step 3. Step 3 equals to, what is the displacement? The displacement is 20 kilometer all over 2. That is the step 4 will be the answer. Step 4. This cancel is 1 into this 10. So what is the velocity? Velocity is 10 meter per second or 10 meter per second. That is the velocity. So they now said a car displaced from a point A 20 kilometer due north in 2 seconds. What is the velocity? Change in displacement of this all over the time. So that is the velocity. And we will also consider another one. For instance, we go into velocity, still velocity. We now say a car or a bicycle or a body, let's call it a body, move from a point A, which is 20, you can say 30 kilometer, to a point B, which is 10 kilometer in 2 seconds. What is velocity? So to find the velocity using the word acronym called IC, we first and foremost, step 1, we said what? Identify the parameters. What are the parameters? 30 and 10. So we now said displacement is what? 30 kilometer and 10 kilometer. Then time equals to 2 seconds. Time is 2 seconds. Step 2. Now what do? Apply the formula of velocity. Change in displacement all over time, which is what? Because it is changed. So it will be 30 minus 10 all over 2. Because it is all over time. That is step 2. Step 3 will be 30 minus 10 gives you what? Gives you 20. 20 over 2. This cancel is 1 into this 10. So the velocity is still what? 10 meter per second. So as we have done that with the velocity that we know, it is the distance, the speed, and the direction. That is what the velocity is all about. Displacement, distance, speed, and the direction. So let's get into acceleration. Acceleration. As we get into the acceleration, we now have acceleration is the rate of velocity, the rate of change of change of velocity move with time. Rate of change of velocity move with time. Acceleration is what? Change in velocity all over change in time. And we can also have acceleration because when this motor moves from one point to another, it has initial velocity, it has initial position, and when it moves to the end, that is a final position. As I'm holding it now, it has an initial position which is u. When it moves to the end of the road, that it has its final position which is v. So v minus u all over t is the acceleration. So we now have a boy, for instance, we say acceleration will now be v minus u all over t. That is the acceleration. So we are going to use this to solve a problem. But before we do that, I want to illustrate what we mean by uniform acceleration and non-uniform acceleration. Uniform acceleration is the increase in velocity all over increase in velocity with time. As the velocity increases, the time also increases. That is what we mean by uniform acceleration. And non-uniform acceleration is that as the velocity decreases, the time increases. So for instance, for non-uniform acceleration is when you are driving your car and you get to a traffic, something stops you, maybe the traffic stops you. That means that the velocity will decrease. Or you match a brake of a car, that means that the velocity will decrease. That is, you are experiencing uniform acceleration. So we now have now been able to explain what we mean by uniform acceleration. Uniform acceleration is increase in velocity with time. While non-uniform acceleration is the decrease in velocity. Non-uniform acceleration is the decrease in velocity with the time. So we can now experience that acceleration is a change of velocity with time, or change of velocity divided with time. Uniform acceleration is the increase in velocity with equal time, no matter the small amount of time. While non-acceleration is a decrease in velocity and with the time. So as we are going to consider, you should check the differences between non and uniform. So let us proceed in solving a problem in acceleration. We now say acceleration, a car travel, we call it accelerate. A car accelerates from 5 meters per second to 15 meters per second. 15 meters per second in 5 seconds. What is the acceleration of the car? What is the acceleration of the car? So in this case, the acceleration using the step called IC, the acceleration of the car is, we have first and foremost step 1. You need to bring out the parameters. These are the parameters. That is from U is 5 meters per second, and V is what? 15 meters per second. That is U and V. And time T, that is step 1. Step 2, T is what? T is 5. And the acceleration is unknown. Acceleration is unknown.
Okay. 3, 2, 1, action.
This car accelerates uniformly from 5 meters per second to 15 meters per second in 2 seconds. So what is the acceleration? We know that acceleration is a change in velocity all over time. So we now say step 1, using the word acronyms. I'm using the acronyms called IC. We have seen this. That is the step 1. Step 1 the parameters. We said u is 5 meter per second and v is 15 meter per second. So in step 2, we are going to bring out the formula for acceleration, which is a equals to v minus u all over t. And in step 3, we are going to substitute these values into this formula, which we said v is 15 minus 5 all over t. That is step 3. In step 4, we solve it, which is 15 minus 5 all over, what is the time? 2. This is equals to 10 over 2. So step 4 is 10 over 2. 2 cancel the same one into this 5. So now step 5, which is the solution, which is where we have the execute the answer, which is where we have 10 over 2 equals to 4. No, sorry, 10 over 2. 2 cancel the same 1 into this 5, which is 5 meter per second squared. That is the acceleration. We can also say that acceleration is the change in velocity all over time. And also, don't forget to understand that in solving problem in acceleration, there's what we call uniform and non-uniform. Uniform decreases as the body accelerates. While in a uniform, it increases. The velocity increases. So I have made that explanation to you. So at the end of this lesson, you should be able to understand what is velocity, what is acceleration, how do we derive acceleration formula, what is the difference between uniform acceleration and non-uniform acceleration, what is average speed, velocity. Average speed in velocity is total average speed, call it average speed or average velocity is equals to total average velocity is equal to total displacement all over the total time. Total displacement all over the total time. So in solving this will be u plus v all over 2, because we are talking about average. It will not be time. It will be 2 divided by 2 because we are talking about the average. So it's initial velocity plus the final velocity all over 2. That is what we mean by average velocity. So we should also consider that if we throw this ball up like this is under motion. But if we use in the horizontal, which is a translational motion, which is linear motion, a ball slow from one point to another. What happened? A ball slow from one point to another. What happened? It has changed its velocity with time. And remember, when you are maybe trying to play a tennis ball, get into the court, what happened? It will slow down before it gets into the court. That means that as the body tends to slow down before it gets into the court, that is non-uniform acceleration because the velocity is reducing. As a body tends to be at the traffic lights, that is non-uniform because acceleration is reducing. As you intend to match a brake of a car, that is non-uniform because acceleration is reducing. But if you are moving forward, that is a uniform acceleration. So in this class, you are able to understand what we mean by velocity, acceleration, non-uniform, and uniform, and how to calculate velocity and how to calculate acceleration. So in the oral class, we are going to consider what we mean by equation of motions, where we solve problems using the parameters. Before you end this class, please remember to click share at the bottom below, and this will continue to motivate me